Lesson 11.5, using recursive rules with sequences. What we've used so far are explicit rules. The explicit rule gives the nth term directly. So if you want to know the 10th term, you'll plug in a 10, like this. If you want to know the 10th term, it would be 2 plus 4 times 10, or 42. A recursive rule, each term is found by knowing the previous term. So it's like I know that I'm adding 4 each time. So if I know the first term is 6, and then the next one is 10, then the next one is 14, it's written like this. For a recursive rule, you have to know where you start, and then you have a rule. Now this part of it, this an minus 1, that means the previous term. So it's the previous number plus 4. So a1 is 6. That means a2 is 6 plus 4. a3 would be 10 plus 4, or 14. a4 is 14 plus 4. Just take the one you had before, and in this case, we're adding 4. Question is, why would you want to do that? Well, quite possibly because sometimes the recursive rule is very much easier to make and find than the explicit rule. All right, so let's write the first 5 terms. Well, the first one's easy. They gave it to us. It's 3. All right, a2, now we're using this, is 2 times this an minus 1 means the previous term. What did we have before? 3. So that's 6 minus 1 is 5. a3 is 2 times the previous term. So it's 10 minus 1, or 9. a4 is 2 times the previous term, which is 9 minus 1. 18 minus 1 is 17. a5 is 2 times the previous term, minus 1. So that's 34 minus 1 is 33. Why don't you try number 5? So you should have 5, 26, 677, I forgot the 2 to begin with, and 4, 5, 8, 3, 3, 0. There are a couple special recursive rules. We did arithmetic sequences and geometric sequences. Remember, arithmetic sequence is adding. So it is your previous term plus d. Geometric sequences are multiplying. So it's your previous term times the r. All right, so let's write the rules for the arithmetic sequence where a1 equals 15 and d is 5. Let's start with the explicit. Remember, the explicit rule for arithmetic sequence was an equals a1 plus n minus 1 times d. a1 is 15, d is 5. Remember to distribute, so that's 5n minus 5. So 15 minus 5 is 10, so it's 10 plus 5n, or 5n plus 10. For the recursive, we're adding to the previous term. So it's an minus 1 plus d. So remember, you have to say where you're starting. So we're starting at 15. And then an is an minus 1 plus d. All right. Let's try writing the rules for the geometric sequence. For the explicit rule, remember, is an equals a1 r to the n minus 1. So in this case, a1 is 4, r is 0.2. There you have it. For the recursive rule, you're multiplying, so it's r times your previous term. So remember, you have to say where you're starting. So we're starting at 4. Then a1 is r times the previous term. All right, let's try writing the recursive rule for this sequence. It doesn't appear to be arithmetic, because for the first time we add 0. Doesn't appear to be geometric, because then it'd be multiplying by 1, and then, yeah, so no, it's neither. So we have to figure out what it is. So you kind of look for a pattern. I see a pattern. If I go 1 plus 1, and I times that by 2, it gives me 4. If I go 1 plus 4 times 2, it gives me the 10. If I guess 4 plus 10 times 2 gives me the 28. So this appears to be 2 times the two numbers before. So an minus 1 is the one before. An minus 2 must be 2 before. So if I'm looking at 4, this is the an minus 1, and this would be an minus 2. So I'm adding those together and multiplying by 2. But then we have to say where we start. And since we're going 2 spaces back, we have to have the first 2 terms. Why don't you pause this and try number 13. Did you catch it? Looks like you're dividing by 4 every time. Dividing by 4 is the same thing as multiplying by 1/4. So this is actually geometric, where r is 1/4. You know a1. So say where to start. And for geometric, an was r times an minus 1. All right, let's write a recursive rule for this. Now this is explicit already, right? So we want it recursive. But what type is this? This appears to be linear. That means it is arithmetic. Let's come up with the first couple of terms. A1 is 30 minus 5 times 1, or 25. A2 is 30 minus 5 times 2, or 20. A3 is 30 minus 5 times 3, or 15. So it appears like A1 is 25, and the D is -5, or going down by 5. All right, so the recursive rule was n minus 1 plus d. All right, you have to say where you're starting. A1 is 25, and then an equals an minus 1 plus a -5, or just -5. Why don't you try number 29? This is exponential. This tells you it is geometric. This one you know is a1 r to the n minus 1. So a1 is 12 and r is 11. And for geometric recursive, you know it's r times a(n minus 1. You have to say where you're starting. a1 is 12. And then a(n), r times a(n minus 1. All right, let's go the other way and write an explicit rule for the sequence. Well, notice here I am adding, so that means it is arithmetic, where d is 4. So arithmetic is a(n) equals a1 plus n minus 1 times d. a1, we're told, is 7. And d is 4. Distribute. And then 7 minus 4 is 3. Why don't you try number 39? We're multiplying, therefore it is geometric, and that is the r. So it's a(n) equals a1 r to the n minus 1. a1 is negative 2. R is 3 to the n minus 1. Let's try a problem here. A controlled laboratory contains about 500 mosquitoes. Each day 100 new mosquitoes hatch, but the population declines by 85% due to a pesticide and natural causes. Write a recursive rule for the number of mosquitoes at the start of the nth day. Well, what happens every day? So every day we add 100, but the population declines by 85%. If it declines 85%, we still have 15%. So, what's going to happen? We're going to take, we still have 15% of the previous day, but then we're going to add 100. And remember, it's recursive, you have to say where you start. We start with 500. Find the number of mosquitoes at the start of the 4th day. All right, well, it's recursive. A1 is 500. A2 is 0.15 times the previous day, which was 500, plus 100, which gives us 175. A3 is 0.15 times the previous day, which was the 175, plus 100, which gives you 126.25. I know you can't have a quarter of a mosquito, but work with me here. A4, 0.15 times the previous day, plus 100, is 118.9375. So our answer is about 119 mosquitoes. So what happens to the population of mosquitoes over time? Well, we can pull out our calculator and we can put in our little formula. So we have 0.15 times the previous day. In this case, it's going to be 500 plus 100. So this should give me the A2. Now what I can do to find A3 is I go 0.15, but this time times the previous answer plus 100. You can see that's day 3, day 4. I can just keep hitting enter now, and it gives me the next day. So day 5, day 6, day 7, day 8, 9, 10. And it's looking like it's not changing anymore. So it's approaching 117.64705888, or approaches about 118 mosquitoes. So the population will stay about that. All right, try number 53. You borrow $2,000 to travel. The loan has a 9% annual interest rate that's compounded monthly for 2 years. The monthly payment's $91.37. All right, so how this works is you multiply your interest rate by what you have and you add that amount to it. Well, our interest rate is 9% annually compounded monthly. So every month it would be 9 divided by 12, or 0.75, which means we're going to multiply by 0.0075, but we're going to make that a 1 so that we have what we had before and this extra interest. So AN is going to be that number times what we had before, and then we'll subtract the amount you pay. And we're starting at A0 is 2,000. So A1, now why did I call it A0? Because this is the amount before you have paid any payments. So that's after the 0th payment. So after the first payment, they're going to charge interest on that $2,000 and then subtract the $91.37, which gives you $1923.63. A2, after the second month, they charge the interest again, but only on the amount that was left before, the $1923.63. And then you pay $91.37, which gives you $1846.69. A3, they're going to charge interest again on your previous balance, and then you'll pay $91.37, which is $1769.17. Fourth month, they'll charge interest on your previous balance, and you'll pay the $91.37, which is $1691.07. The fifth month, they'll charge interest on your previous balance and subtract $91.37. And you'll end up with $1612.38. So, after the fifth month, you still owe $1,612.38. So, let's find the amount of your last payment. So to do that, we could use a calculator, and we could run this recursively again. So we'll start by putting in that. After that, we'll put in that, and we'll very carefully, we're going to do 24 payments. So we'll have to very carefully count. So calculate the first month, and then times the answer now. So it's month 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. I didn't calculate one when I counted, but anyway, it looks like our last one will be $90.68.